My name is Muhammad Faizan. My roll number is 22. Today I will discuss varying volume batch reactor. So let's start the topic. What is varying volume batch reactor? It is most commonly used in case of the microprocessing feed. Suppose if we consider very small reactor like this, so we can consider a bead kept over here in a tube, and then as soon as the reaction process starts, the bead will move because the bead is movable. Because the bead is movable, the volume of the reactor will change. So V naught, the initial volume of the reactor, and V, the volume at time t. And in general, what we do, we operate this reactor at constant pressure and isothermal condition. That means as soon as the volume reaction change, we move the bead, keep the total pressure of the reactor same or constant. Generally, we keep the operation isothermally. So if we consider a volume and conversion relation is linear, so we can write for this V would be equal to V naught into 1 plus epsilon A into XA, or XA would be equal to V minus V naught over V naught into XA. When we differentiate this equation, we can get this equation: dxa equal to dv over v naught epsilon a. So we have epsilon a means the fractional change in volume. So this fractional change in volume happens between no volume conversion and complete volume conversion. So from above definition we can write epsilon a would be equal to Vxa at 1 minus Vxa at 0 over Vxa at 0. Vxa at 1 means complete conversion, V at x0 means no conversion. Let us take an reaction. So we will see how to calculate epsilon A. Consider the isothermal gas phase reaction in which A would be converted into R. Start with a pure A. According to stoichiometry, 1 mole of A produce 4 mole of R. So epsilon A would be 4 minus 1 over 1 would be equal to 3. But with 50% inner present at the start, two volumes of reactant mixture yields one complete conversion, 5 volume can 5 volume of product mixture. So with that means if we take 2 volumes of A, it will produce as per the stoichiometry 8 volumes of R. But we have 50% inert, so we had 1 volume to 4 volume product, so total 5 volume, and then we had 50% inert with it, so epsilon A will be equal to 5 minus 2 will be equal to 1.5. So now we discuss relation between concentration and conversion. As we know that Ca over Na, Ca is equal to Na over V, and we know that Na will be equal to Na naught into 1 minus Xa, and we also know that V will be equal to V naught 1 plus epsilon A into Xa. Simply we substitute these two values into this equation, so we can get this equation. Ca will be equal to Na naught 1 minus Xa over V naught 1 plus epsilon A into Xa. We know that Na naught over V naught will be equal to Ca naught, so simply we replace Ca naught with Na naught over V naught, and by rearranging above equation we can get Ca over Ca naught will be equal to 1 minus Xa, or with in terms of conversion Xa will be equal to 1 minus Ca over Ca naught over 1 plus epsilon A Ca by Ca naught. Rate equation for varying volume based reactor. Now we discuss the rate equation. As we know that the rate of reaction is in general will be equal to minus Ra equal to minus 1 over V d Na over dt. So simply replacing V and Na from this equation. So we know that Na will be equal to Na naught 1 minus Xa. Simply we differentiate this equation and replace Na from this equation. So we get the equation in terms of conversion. So minus Ra will be equal to Ca naught over 1 plus epsilon A into Xa dxa over dt. In terms of volume, minus Ra will be equal to Ca naught over V epsilon A into dV over dt will be equal to Ca naught over epsilon A into d ln V over dt. So we have an equation of rate equation of a varying volume based reactor. So we discuss next the exercise problem relating the varying volume based reactor. So start. Find the first order rate constant for the disappearance of A in the gas reaction. The reaction 2 moles of A converted into 1 moles of R If on holding the pressure constant, the volume of the reaction mixture starting with 80% A decrease by 20% in 3 minutes. So this the solution of this problem is here. As we know that the initial volume V naught and the change in volume V would be equal to 80% of V naught, means initial volume. Then the reaction, we consider the reaction in which 2 moles of A converted into 1 moles of B. As we know that 80% complete conversion gives 40% of B and the 20% of inerts, which is same in after and before the process or operation. So we have total volume V naught will be equal to 1, Vxa at 1 and Vxa at 0 will be 1, means no conversion. After complete conversion we have 0.6, Vxa at 1 is equal to 0.6. So the fractional change in volume would be equal to 0.6, means complete conversion, minus 1 means no conversion, over 1. So we have epsilon A would be equal to 0.4. As we know that first order rate constant equation for varying volume based reactor would be equal to minus ln in epsilon A plus 1 minus V over V naught over epsilon A equal to KT. So we have to find out the rate constant. Simply we substitute all the value which is given in the problem. So we substitute the value, we compute the value, and we get the result K would be equal to 0.23 per minute. Thank you.